Hi everyone and welcome back. In this video we're going to introduce a new data type called Boolean data types. Boolean refers to true or false. True or false. So this data type is going to have only one of two conditions, right? It's either going to be true or it's going to be false. That's it. Okay, so the range, right? The range of this data type is just true or false. Okay, those are the only two values that are kind of in the set of that data type that are in that range. Okay, so we're going to declare it using the word bool. Okay, and then the variable name. Now the variable name tends to, we talked about conventions in a previous video. The convention for Booleans tends to be written in a way in which we're clearly indicating that there's some sort of true-false condition. So often it might be like is valid or is male or something like that, where you're talking about a true-false condition. You know, you can have something, or maybe something like has, like something like a has driver's license, for example. Okay, and we're going to indicate it as a true or false. Okay, so we actually initialize it and use it as a true-false value. Okay. Now, this is a type of data type that we refer to as a non-primitive data type. We've talked about primitive data types before. The big difference between a primitive and a non-primitive data type is we can build non-primitive data types based on the primitive data type. So let me give you an example. Okay, true-false is literally we can indicate with a single bit. Okay, where 0 refers to false and 1 refers to true. Okay, so you only need a single bit for being able to distinguish between one of our two values. Okay, now you know, kind of a minor point at this stage in the game, but the smallest piece of data that we're going to be able to store is actually a single byte, which is 8 bits, but that's a nuanced point at this stage. So we can have you know, we can use this small amount of information, 1 byte or 1 bit, depending on how you want to look at it, to represent just the 0 or 1 to representing our true-false condition. Okay, so we can build that using the primitives, and the way that this works in C is if we want to use these Boolean data types, we're going to use a library that effectively constructs this data type from those primitives. Right? Now, if we're going to add the library, it's std_bool, right? STD stands for standard. It does not stand for sexually transmitted disease. Standard, okay? Standard Boolean library. And then we have that access, that functionality. We're bringing it in. Okay. So let's look at this example. I'll pull it up in the IDE, and we'll be able to kind of see it in action. Looking at this example here, let me kind of show you a couple things. We're declaring a bunch of variables here. All right. Now, I've shown you in previous videos that oftentimes when you're declaring variables, it's actually good practice to initialize them right away. All right. The exception to that rule is if you're you know, if you're making sure that you are initializing them prior to them being used. Okay, so in this example here, we're declaring them, these 5 variables. That's fine to do, right? Because we're making sure that we are initializing them prior to ever reading them, right? You never ever want to read a variable prior to it being initialized. Okay, now what this program does is it actually computes the life expectancy of an individual based on 2 pieces of information. Okay, the person's gender and the person's BMI, basically their weight. What happens here is we're going to set 2 Boolean variables to true or false based on input from the user. Right? If the person's BMI is too high, we're going to set is overweight to true. Otherwise, it'll be false. And if the person's male, we're going to set that to true. Otherwise, to false. Okay, so let's look at the gender first. We're going to have the person type in F for female, M for male, right? We're going to get that from the user, that character, so we're using that format specifier for character, And if they're a male, we're going to set that Boolean to true. Okay. Otherwise, we're going to set it to false. All right. Then we're gonna prompt the user to enter their BMI. All right. If it's above, equal to, or greater than or equal to 25, we're gonna set overweight to be true. Okay. So let's take a look at this expression here. This is a little bit new. We haven't seen this before. Now, notice this actually is going to evaluate as a true or false condition, as a Boolean condition. Okay, what we're doing here is we have these operators, this greater than equal to operator here. And if that operator, right, it's going to say, it's basically asking a question. It's saying, is the user's BMI greater than or equal to 25? Right, the end result of that is going to be true or false. Okay, it's going to be true or false. So that is going to initialize this is overweight variable accordingly. Okay, so we can do things like that. We can use these operators that evaluate true or false. It doesn't have to only be in the context of a if statement, of a branch statement, right? You can use them other places, and you can set Boolean values accordingly. Okay. Now, once we have those two Booleans set, how this program is going to work is we're now going to evaluate. We're going to have these conditional statements here, and we're going to just determine, right, the combination of values to determine what the life expectancy is. So in this case, what we're saying is if the person's male and they are not overweight, okay, not overweight. Now notice the exclamation point, right? We've got that negation there. We got that negation. We're saying if they're not overweight. Now this is equivalent, by the way. Okay, this is equivalent to me doing this. Okay, that writing it that way is fine. It's completely legal. It's going to work the exact same way, right? However, oftentimes when we use Boolean logic, we tend to shorten it, right? When we're using these Boolean data types, we tend to shorten it by instead of saying is male equal to true, it's implied here. This is going to evaluate. This is Boolean. It's going to be a true or false. It's the same thing. And rather than checking if it's equal to false here, I could check if it's effectively not true. It makes the code a little bit more concise, and I would argue it makes it more readable. Okay. However, you can do it any way you want. I don't really care. I mean, it's the same logic, and it's not a big deal if you prefer to write it that other way. Okay. Now the next else if we're saying if they're not male, so female and not overweight, then they're going to have a greater life expectancy, right? And then this one is male and overweight. Right, lower life expectancy, and then we have the final combination here, which would be females, not male, and is overweight. Okay, because we've got, if you've got two Boolean values, right, they can only be true or false each. So you've got 4 different possibilities, and that's effectively what this is indicating here. And then we're going to print out the value. So I'll run this so we can see it in action. What this code looks like. We're saying, okay, male or female. I'll type in male. I'll type in a BMI, and we're going to get the life expectancy. Okay. All right. Now, let me show you one other example. Okay. Now, before I show you that other example, let me point out one thing here. Right. Boolean values are effectively stored as 0 for false and 1 for true. So if I did something a little bit, let me just print out here down. I'll do it right at the bottom. I'm going to print out the value for is male, and I'm going to use the format specifier here, D, for integer. Okay. And then I'm also going to print out the is overweight value as an integer. Okay. And I'm going to print. So we've got, so what I'm doing, right, is I'm printing out is male and is overweight, and I'm just printing them to the screen. I'm printing them as an integer, right? And what I want to show is how true and false is getting an indication of how they're being stored and how they're effectively it's a one bit that's really being effectively used, right, for determining true or false. So I'll type in the same information from before. If I think I did this way, we have one true and one false. Okay, and what we see here is, right, is we're saying, well, is male is 1 for true, right? I printed out as an integer. 1 indicates true. And the BMI here was under the 25. So is overweight is false or 0. Okay, so that's effectively what that is. So if you see, you can actually, sometimes you even see people doing things where they're effectively using 1 to indicate true. You might see that on occasion, and that's important to note. Okay. All right, one quick little example here to kind of just bring this point home. Let's imagine, now, as engineers, right, especially when we're talking about electro and computer engineering, we're gonna want to, as you kind of go through the curriculum, basically build things, right? And oftentimes, what we want to do when we build systems is we want to have some sensor information, reading some information into the system, and then we're going to have some actuation. We're going to have something happen in the environment. Okay. Now, we're not focused on that in this class, but we're kind of building a foundation to help you have the programming knowledge to be able to do that. So let's just think of an example here. Let's look at an example here where we have something along those lines. So let's imagine we've got a room or home. Yeah, let's draw it as a home. There. This is my beautiful home with my excellent my excellent drawing skills here. And let's imagine that this home, it's got some sort of AC unit here. Okay. And it also has a some sort of evaporative cooler system as well, that I'm just going to label as a EC for evaporative cooler. Okay. And we want these systems to automatically turn on and off, okay, with no user input. Okay. So let's imagine we've got, so these are our actuators, right? We've got these things that actually do something in the environment. They do something. And we're going to have 2 sensors in here. Okay, one that determines the temperature, and one that determines the humidity. Okay, and let's have these sensors hooked up in such a way that there's some sort of computing system that combines all this. Right, this is going to be our computer, right? Our computer system, or maybe really often referred to as a microcontroller that has a program running, and it's going to connect all this together. Okay, now what would the logic look like, right? What we're thinking about from a programming perspective is, what does the logic look like and how that's going to run? What we want to have happen is that if the temperature is too high, right? If it's hot, we want the AC to turn on, right? And if the humidity is low, we want the evaporative cooler to turn on. So we're gonna regulate the temperature using these 2 different systems based on that. So here's what the logic would look like. What the logic looks like here. All right, I'm skipping a couple things, but remember, these are Booleans here. Okay, is what we're doing, and actually effectively we're not even using this is really hot example. Okay. We're determining, right, if this isn't showing the entire program, but it's hitting the main point related to Boolean logic. Is we're saying, okay, if the current temperature is greater than the desired temperature, okay, we're going to set this is hot variable to true, otherwise it will be false. Okay, and if the humidity, okay, if the current humidity is greater than 0.5, we're going to set is humid to true. Okay, based on that logic here, we're going to turn the AC and evaporated cooler on and off accordingly, right? Right? There's only one of 2 conditions. We're either turning the unit on or we're turning it off. We're not doing any sort of midway or any sort, it's on or off, right? And you typically see your ACs, work that way. All right, so we can see that the rest of the logic flow is very similar to the previous thing that we showed. Now, why am I showing you this? I'm showing you this to kind of get a general sense of how programming logic's used, or particularly Boolean logic is used in the context of building more complicated real-world systems and tying it in with what we refer to as either like Internet of Things or smart homes or these types of kind of physical systems.